In this lesson, we will complete the task of creating the delayed flashing effect of LEDs. Next, we will explore the following topics. Many cities have beautiful nightscapes, largely due to various lighting displays, and a crucial aspect of these displays is light control. Our task is to use a microcontroller to achieve LED control with a delayed flashing effect. Let's start with a basic example of using a microcontroller to control the flashing of an LED. In our previous lesson, lighting up an LED, we have learned about the complete design process of a microcontroller application system. We have understood the principle of LED lighting, but how do we achieve a flashing effect? Looking at the simulation circuit, we see that the LED is continuously on, not flashing as required. By modifying the circuit slightly, we add a button switch. Clicking the simulation button shows that the LED does not light up. However, pressing the switch causes the LED to turn on. By continuously pressing the switch, you can achieve the flashing effect of the LED. Although this method can achieve the flashing of the diode, it is highly labor-intensive as it requires a person to continuously press the switch. Here, we present a circuit using a microcontroller to control the LED flashing. The circuit includes an AT89C51 chip at the center, with internal clock circuitry and power supply on the left, and the LED connected to the P3.0 pin with a current limiting resistor on the right. When the P3.0 pin outputs a low level, the LED lights up. Conversely, when the P3.0 pin outputs a high level, the LED turns off. By alternating between high and low levels, we achieve the LED flashing effect. Next, we will discuss how to control the P3.0 pin to alternate between high and low levels. The control program is designed in C language. After compiling, an executable file is generated. By double-clicking the circuit diagram and selecting the generated executable file, we link the control program to the circuit. Running the simulation will show the LED being controlled and flashing as expected. Let's briefly review the design of the C language program. The flowchart for controlling the LED flashing with a microcontroller is shown. The overall program structure consists of sequential and loop structures. A C program consists of one or more functions, but it must contain at least one function, namely the main function. Functions are defined by a function name followed by parentheses, with the function body enclosed in curly braces, which are the two most recognizable parts of a function. In terms of syntax, the program is composed of statements. Statements in C language can be executable or non-executable. Executable statements end with a semicolon. For our task, the control program is structured with two functions. After the commands to turn the LED on and off, we add a delay of 1 second. The microcontroller operates very quickly, and without a delay function, the LED flashing speed is too fast for the human eye to observe. You can try removing the delay function after class. The main function is the entry point of the program. Note that the execution of a C program always starts from the main function, regardless of the order of writing. The first line includes header files. The second line defines variables. SPIT is a data type in C language with a single bit. LED0 is a variable name defined as an SPIT type, representing the output value of the P3.0 pin. Pay attention to the notation for microcontroller I/O ports and bit definitions. The delay function's body contains multiple statements. The first statement defines variables. Below is a two-level nested loop. The main function also contains a loop statement. Note that the loop contains multiple statements, which we refer to as a compound statement. A compound statement is also enclosed in a pair of curly braces. The program execution begins at the main function. The while loop checks the condition in parentheses. Here, the condition is a constant, but it is usually a variable. A value of 1, true, executes the body loop of the while statement and the statements within the following pair of curly braces. LED 0 equals 1 sets the pin to high level, turning off the LED as analyzed previously. Because the computer executes quickly, a delay program is called here to allow us to observe the change in the diode state. The first statement in the delay function body is a variable definition, which defines two integer variables, I and j. Below is a nested loop. As long as the loop condition is met, the loop body is repeatedly executed. The for loop is one of the most commonly used loop structures in C language programs. The parentheses following the for contain the loop condition, which actually consists of three statements. I is the loop variable, and I equals 0 initializes this variable. The loop condition checks if I is less than or equal to 100. If this condition is true, I is increment by 1, and the loop body is executed. The loop body itself contains another for loop, which follows the same execution process. If the condition is false, the loop exits. The approach used here is a nested loop, similar to the way a clock's minute and second hands operate. The second hand completes one full rotation while the minute hand moves forward by one step. When LED equals 0, the P3.0 pin outputs a low level, causing the diode to light up. The process is the same as described above because the value inside the while loop's parentheses is always 1. This process alternates between the LED being on and off as the while loop condition remains true. Today, we learned how to control an LED flashing with a microcontroller, understood the control functions of the microcontroller, and reviewed the design process of the control circuit. We also interpreted the delayed flashing program for the LED. Please practice more after class to master the relevant knowledge, especially regarding C language, due to its complexity. Seek additional resources if you encounter difficulties. Finally, please complete the following exercises after class. That concludes this lesson. See you next time.